Good day everyone, welcome to TESTS channel. Today, we're going to discuss another topic. Don't forget to like, share, and subscribe for more tutorials. Thank you and God bless.
Good day everyone, welcome again to TESTS channel, and for today's topic we are going to discuss all about tests on alternator. So let's get started. So class, for the content we are going to discuss a short circuit test, secondly open circuit test, third is the DC resistance test, and lastly we're going to solve problems with regards to these topics. So we go now for the first topic, that is a short circuit test. Short circuit test, as you can see in the figure class, so the armature terminal are short circuited with a small field circuit is applied. Adjustment may be made such that the I phase is approximately equal to the rated load armature current per phase. Okay, so as you can see class, yan yung ating ammeter, series dyan, yung ating measuring instrument. And this is the Y connected generator, and then this one is the delta connected generator. So here, for us to have the short circuit current, ayan, so ang value daw noon class is the reading of the ammeter. And po, so yung A dito is the ammeter reading during the test. Ayan. And then, if it is in Y connected, ayan, take note na class that this formula is applicable only in Y connected generator. And this one is in delta. So we have the reading of the ammeter over ng square root ng 3. So that is the value of our short circuit current in delta connected generator. The next one class is the open circuit test. So open circuit test, as you can see in the figure class, the armature terminal are open circuited, and the field current is made equal to the field current during the short circuit test. Okay, so ayan. So itong ating gamit ngayon na instrument is the voltmeter, which is, kung makikita natin classes, we can notice this is naka-parallel. Parallel dyan sa ating mga terminals na yan. And then, ito naman yung itsura niya dito sa ating delta connected. Ayan. With armature winding circuit open, operate the alternator at a synchronous speed. So connect a DC source to the field, making provision to adjust the field current so that yung ating starting zero, it may be raised until the AC voltage between any pair of terminal of armature winding is somewhat above the rated EMF. So here class is what you can say is the Y connected generator, that is to the value of our voltage at open circuit in Y connected is yan yung ating voltage over na square root ng 3. Yan, so that is our formula getting the ating EOC or the voltage generated dyan sa ating open circuit. And then the next one is if it is in delta connected, ayan, so the voltage would be equal dun sa ating reading ng ating voltmeter during the test. Yan, pagka naka-delta connection na. Okay, so the EOC would be equal to the reading of the voltmeter during the test. And now we go to our next topic, that is DC resistance test. So DC resistance test is determined using ohmmeter. So the DC resistance per phase is to be determined. So ito yung ating illustration class, as you can see. Yan, ito yung ating Y connected generator that we parallel o naglalapit tayo ng ating instrument ohmmeter and to get the reading. At ganun din sa ating delta connected generator. So ito yung ating Y connected generator wherein we have the armature DC resistance per phase, that is yung ating RA. Ano po yung yan, yung ating mga RAs. And then yung ating R total or RT na ayan, nakita natin naka-connected dito, naka-parallel, is the DC resistance of the alternator between N2 terminals. And it is also the reading of the ohmmeter during the test. So next one, class, is the delta connected. So wherein yung ating formula is in getting RA is ayan, 3/2 ng ating RT. Ayan. So unlike dun sa ating Y connected, that is 1/2 ng RT, ito is yan, 3/2 ng ating RT. Ayan. So okay, so the next one is, so reminder, class, in practice it is customary to multiply the DC resistance RA by a factor of 1.25 to 1.75 to obtain the value more nearly equal to the armature resistance when it carries AC current. So class, ayan, so naglaro lang yung ating factor nga to 1.25 to ayan, 1.75. But sa problem naman, class, ibinibigay naman yun kung ano yung ating magiging multiplier. Ano po? Ayan. But hindi naman nabigay, so i-assume nyo na lang na 1.5. Ayan. So, ayan. Pero mostly naman ay nabibigay naman yan sa problem natin. So, ito naman, so alternator parameter derived from the test. So, we have yung ating ZS is equals to yung ating EOC over ng ating short circuit current. Okay, so yung ito naman S natin is equals to square root ng ZS quantity squared minus yung ating RA squared. And then ito yung ating mga ibig sabihin niya. So XS natin, that is asynchronous reactance per phase. ZS, that is synchronous impedance per phase, yung ating armature resistance per phase. EOC is the open circuit voltage per phase. And then, ito yung ating short circuit armature current per phase. Okay, that's all for the theory. And let's go now to the problem solving. Okay, sample problem number 1. A generator is rated 100 megawatt, 13.8 kV, and 90% power. A Y-connected alternator has tested for its effective resistance. The ratio of the effective resistance, the ohmic resistance, was previously determined to be 1.35. A 12 volts battery was connected across 2 terminals, and the ammeter read 120 amperes. What is the per phase effective resistance of the alternator? So now we proceed to the solution. So given class is we have yung voltage at DC, that is 12 volts, and the current in DC is 120 ampere. So the condition in getting the effective resistance, that is 1.35 ng ating RA, which is yung ating armature resistance. Okay, so the required niya is the effective resistance. Ano po? And the formula to be used is first we will get the RT, okay, or yung terminal resistance, that is EDC over ng IDC, and getting the RA, but that is 1/2 ng ating RT. Okay, RA is equals to 1/2 ng ating RT, and then yung ating effective value, that is 1.35 RA. So yan. Okay, so finding the RT, so let's proceed sa solution. So una is we will get the value of RT. So okay, so we use this formula, EDC over ng IDC. Substitute natin yung ating mga given. So 12 over ng 120, and we will get 0.1 ohms. So we get the value of RT. So the next one is finding the value of R1. So substitute natin ngayon yung ating nakuhang value ng RT to for us to get the value of RA. So 0.1 divided by 2, and the answer, class, is 0.05 ohms. So now we have the RA. And then, isa-substitute natin ito ngayon dun sa ating formula para makuha si effective resistance. That is 1.5 ng ating RA daw, diba? So, 1.35. Okay? So, the next one, class, is finding the effective resistance. That is 1.35 ng ating RA. So, ayan. Effective resistance is 1.25 ng ating RA. So, substitute natin yung ating nakuha value ng RA dito, class. So, that is 1.35 multiplied by 0.05. And, class, we will get the value of 0.0675 in 4 decimal places na to, class. Ayan. The effective resistance is 0.0675 ohms. Okay, so this is our answer. So check natin if we have right answer. Yan, tama ba yung ating sagot? Check natin. Ayan, for the final answer. Ayan, so we get the effective resistance of the alternator, that is 0.0675 ohms. So tama naman tayo, class, for our computation. And then next, we have the sample problem number 2. A generator is rated, again, 100 megawatt, 13.8 kV, and a 90% power factor. The effective resistance is 1.5 times the ohmic resistance. The ohmic resistance is obtained by connecting two terminals to a DC source. The current and voltage are 87.6 ampere and 6 volt respectively. What is the effective resistance per phase? Okay, class, so yun pa rin ang hinahanap. Okay, so we go now to our solution. For the given, we have the EDC that is 6 volts, IDC that is 87.6 ampere, and the condition for our effective resistance that is 1.5 of our RA. Okay, or the ohmic resistance required. So since walang nabanggit if it is Y connected or delta connected, so we will get the two. So if it is in Y and if it is in delta. Okay, so the next one is the formula to be used. Okay, so ganun pa rin. So yung RT natin is the EDC over the IDC, and ito naman naging dalawa na sila, which is RA that is equals to 1/2 ng RT if Y connected, and if delta, yan, RA is equals to 3/2 multiplied by RT. Okay, and the effective value is equals to 1.5 ng ating RA. Okay, for the solution, finding the RT, so EDC over ng IDC, that is equals to RT, and then substitute the values. So we have 6 over ng 87.6, and we will get class the value of RT, that is 0.068493.5068 ohms. So kita natin hindi ako nag-round up class. So ayan, then the next one, finding the RA if it is OY connected. So yan yung ating gamiting formula. Substitute the value of RT, that is 1/2 ng ating 0.0684931508 068. So the answer would be, ayan, the value of RA at Y connected is 0.0342657534 ohms. And then the next one is finding the effective value if it is Y connected. So multiply lang natin by 1.5. Okay, yung ating nakuha RA, and we will get the value of, okay, so what is the value of our effective value if it is in Y connected? So ayan, 0.0514 ohms if it is Y connected. So kindly check kung pares po tayo. And then the next one is finding RA if it is delta connected. So ito, naging 3/2 na siya ng ating RT. So substitute the value of RT, 3/2 multiplied by 0.0684931508. So the answer would be, class, 0.102739.726 ohms. So that is the value of our RA in delta connected, and finding the effective value in delta connected. Okay, so multiply lang natin by 1.5 again yung ating nakuhang RA. So ayan, and then the answer would be, okay, 0.1541 ohms. That is our computed value for the effective value if it is delta connected. So check natin, class, kung tama ba yung ating naging sagot. Okay, for the Y, that is 0.0514 0.514 ohms, and for the delta, that is 0.1541 ohms. So, yan class, tama naman yung ating naging sagot. Okay class, so that would be all for the tests on alternators. Thank you and God bless. So I hope that you get something and you learn something from this tutorial, and don't forget to like, share, and subscribe for more tutorials. So thank you class, and to God be all the glory. So thank you and keep safe for everyone. God richly bless you.